Today we're going to go ahead and wrap up 4.2. We're going to wrap up the multiplication rule. What have we learned so far? We talked about 4.1. We talked about the addition rule, okay? Remember what the addition rule was? We said or B, A or B is equal to what? A plus B minus the AND part, right? We said this, and we did the Venn diagrams, right? Remember the sports, the female, that one, and then we said if they are mutually exclusive, then this guy goes to 0, and it's just simply this plus this, because mutually exclusive means that they cannot happen together, right? In other words, this guy does not exist. Okay, so that's what mutually exclusive was. And then we talked about the multiplication rule. We said PA is equal to, wait a minute, how did we, okay, so we had PA and B is equal to P of A times P of A given a P of P. What the heck? Given A. Okay, given that A has occurred. Okay, so we talked about this. And what did we talk about in the multiplication rule? We talked about independence, right? We said independence where the two have no correlation together, right? Okay. Remember we talked about Evan wearing red versus, and I think it was Daniel wearing blue or something like that or whatever. We should talk about that, right? So independence. Okay, that's independence. Okay. So those are the two main things that we talked about. What we're talking about today is an offshoot or multiplication rule. We talked about what is called redundancy. And this is a key factor in especially like engineering design, okay, redundancy, a backup system type of thing, okay. So let's go ahead and we're on page 154. Principle of redundancy is used to increase the reliability of many systems, okay. So let's go ahead and jump right into the example 7 there. There's an Airbus 310 example there. Okay. Hannah, go ahead and read that for us.
Where?
Huh?
Which line are you wanting to start?
Example 7.
Okay. Modern aircraft are now highly reliable, and one design feature contributing to that reliability is the use of redundancy, whereby critical components are duplicated so that if one fails, the other will work. For example, the Airbus 310 twin-engine airliner has 3 independent hydraulic systems, so if any one system fails, full flight control is maintained with another functioning system. For this example, we will assume that for a typical flight, the probability of a hydraulic system failure is 0.002.
All right, thanks. So what they're saying there is that we have 3 in the Airbus 310. There are 3 independent hydraulic systems, right? So each one of them, the probability of failure is 0.002. Okay? So A, if the Airbus 310 were to have one hydraulic system, if it only had one, without any backup, right, then what is the probability that the flight control would work for a flight? So in other words, the hydraulic system does not fail, right? Isn't that correct? Because if it fails, it doesn't work, correct? So the probability of it working is 1 minus the 0.002. This is the failure rate, right? Okay. B, given that the Airbus actually has 3 of them, what is the probability on a typical flight that control can be maintained with a working system? Okay. So for it to fail, what has to occur if I have 3 separate ones? All 3 of them have to fail, right? In other words, the first one fails, and the second one fails, and third one fails. Unless some pretty astronomically, you're having a really, really, really bad day if all three of them fails, right? So the probability that it's going to work is that since this is the failure rate, again, now you go like that, right? And if you do that, according to the book, you get 0.99999999992. Okay, that's like way out there. All right. Can you see by putting three of them back to back to back, right? And they're independently, you have three systems, how it greatly enhances the safety feature, right? Okay, because it's just a huge difference, right? So that's what redundancy is, okay? All right. Then we have, what is this? The rationale for the multiplication rule. I have no idea what they're talking about here. Let's see. To see the reasoning that underlies the multiplication rule, consider a pop quiz. True or false? A pound of feather is heavier than a pound of gold. Okay. By a small sample, we may judge of the whole piece. What is this? I have no idea what they're talking about here. Okay, there's multiplying. Okay, so I think all they're doing is that for both to be correct, you have to have correct on both of them, is all they're saying, and you have to multiply both of them together. Okay, whatever. Okay, summary of addition rule and multiplication rule. I already did that, so we're good with that. Yeah, I would not worry about the rationale for the multiplication rule. Okay, so we're all done for the day. We are done for the day. Your redundancy questions today are 25 through 30. So let's work on those. They look fairly long, unfortunately for you guys.